The project in this video is a 2D Arduino plotter. I'm going to be talking about how I assemble it, some programs that I'm running to make it all happen. I'm going to try to put all of the 3D printed STL files and any code that I have in the description. Three main things that I'm going to talk about are Inkscape, Universal G-Code Sender, and GRBL. Those are the programs that will be making it all happen. And we're going to be talking about how to make pictures into G-code, how to send the G-code, how to interpret the G-code, and all that fun stuff. So hopefully if you're watching this video, you'll learn something. I hope the video isn't too boring, but I'm excited, so let's get to it. Boom. Finished the y-axis. Got the y-axis stepper motor put on there. Here. See, I just put this little tiny little 2-inch piece of extrusion here with a 90-degree bracket. Get that. All right, next I'm going to put the pulley on this side and then run the belt with the belt grabber that attaches right here. Yay! Alright, so the assembly is done. Two NEMA 17s running the X and Y axis. Both axes are belt driven. The X axis is mainly 3D printed parts. The housing for the two limit switches are also 3D printed. The platform is made out of acrylic. All the wiring I'll be able to show you guys on the screen for a minute. Pretty much all of this is straight off of the GRBL wiki page. I have two A4988 stepper drivers. They can micro step up to a 1/16 of a step, which can be useful here. I have them in 1/8 step configuration. They've worked really well for me. They were cheap. The only thing I did different is the pin 11, how I controlled the pin going up or down, the writing utensil up or down through this transistor relay circuit. It had to be pin 11 for the PWM, but like I said, most of this stuff you'll be able to find on GRBL wiki page. Alright, so let's talk about GRBL and how I made GRBL work for my machine. It's just a G-code interpreter. The very first page that comes up is the GRBL version 9. I'm actually going to be running version 1.1. We can go to the wiki page here, and this is the page that I mentioned earlier when I was talking about the schematic. It's very helpful. I reference this page a lot. However, this GRBL is made for a 3-axis machine, which would mean a third stepper motor controlling the Z-axis, which mine doesn't have that. I have a solenoid that just goes up or down. So let's talk about how I made GRBL work for my machine. Let's see, GRBL pen servo. This guy right here, GRBL pin servo. This is another guy who was doing something similar as what I'm doing, and he used a servo to control his pen, his writing utensil, up or down, which is similar to what I'm doing, but I have a solenoid. So he actually uses the PWM function of digital pin 11 on the Arduino Uno. So all I did here was download the zip, extract it, move it into my Arduino libraries folder, and from there was a little bit of configuring that I can go into. Arduino libraries, GRBL was the spindle control file, which is what pin 11 controls on the pinout of GRBL. So you can just open that right in the text editor. So this guy, he has some math as to some of the values he calculated to control his servo with the PWM. I couldn't quite follow it, but basically what it came down to was these two values right here, servo up and servo down. I have it at 220 and 3. This 3 could probably be 0, but I just played around with these numbers till something worked, and this worked. So something to note, at first I had these numbers swapped, and when the pin was supposed to be up, it was down. When it was supposed to be down, it was up. Just a quick swap of those, and everything worked fine. And once you have these changed in your text editor, you can literally just save it into the source files and open your Arduino IDE, go into examples, and upload the GRBL upload example, and your Arduino will be flashed with GRBL. Alright, so let's talk about how to make G-code out of pretty much any picture or drawing that you can draw yourself or get on the internet or anything like that. We're going to use a free program called Inkscape. It's a pretty cool program. It's open source. There's lots of different stuff you can do with it. But when you download it, it comes with an extension to create G-code out of any picture or text. So this is what it looks like when you first open it. This is your work area. The first thing we're going to do is go into document properties from the file drop down, and mine is in landscape, and this is where you just format your work area. I'm going to use millimeters and adjust it to the dimensions of your machine, whatever that may be. And once you have that done, you can just X out of there and it will save just like that. We can zoom in here holding the control button and scrolling down. And so I would be able to copy an image from Google Images, or I can use the different tools here that they have to create different shapes and lines. There's also a text tool that I can make any sort of text or anything that I want, and I'll be able to turn all of this into G-code to send to GRBL on my Arduino Uno. We're going to go ahead and select it all. We are going to come into path, object to path. It seems like that doesn't do anything, but it won't work unless you select object to path. So from there, we're going to go into extensions, G-code tools, and orientation points. The 2 points mode, I don't really know what any of this does, but I just select apply and it will work. After a second, you'll see your orientation points show up on your work area. Then you will go into extensions, G-code tools again, and go to your tools library, select default and apply. And this big green box will show up. I'll pull this to the side right here, and this is where you edit values that are specific to your machine. So if we come over here into the text editor, I only mess with 2 values, and that will be feed, and I adjust these values to the maximum travel rate of that I have my stepper motor set for in GRBL, and that would be 1100 millimeters per minute. So once I have that done, I come back into the selector tool, select my shapes, go back into extensions, G-code tools, and path to G-code. And here is where we can make a name for our G-code file. So we'll just call it test.ngc. Here you're going to want to copy the directory of where you want your file to save, your units in millimeters or inches, and I select round all values to 4 digits from the post-processor drop-down. Otherwise your values get really long. You can scale your pictures in the options tab, and then we go to path to G-code, and from here we make sure subpath by subpath is selected, and we apply, and after a minute it should show us where, after we close, our tool is going to travel. So for the square you can see the arrows that it's going to travel, as well as the circle, and with the text it gets a little more busy. But from there we should have a file on our desktop that contains this G-code. Here it is, test. Open that up, and here is the G-code for everything that we will be sending to GRBL via Universal G-code sender, which I will be getting into next. So let's talk about UGS. Universal G-code sender, which is what is going to send the G-code line by line to the Arduino for GRBL to interpret. I have this 2.0 platform nightly build. So this is what the interface looks like. Up here is where you're going to connect. Right now I'm using, there's different firmwares you can use. GRBL, COM9, and it uses 115200 baud rate. And you just press connect, and upon connecting it is going to display all of the settings that GRBL has. See if I can make this a little bit bigger. All the settings that GRBL has in place, and a small description. This is where the wiki page comes in handy. Some of these you're going to have to calculate based on your specific machine. To change one of these values, see this says $0 equals 10, and all I would do is simply type in $0 equals 12 and press enter, and that would change for you. And if you ever need to see this, where the settings are at currently, you just send a double $, and it will resend all of the settings that GRBL is set to. Now notice I have an alarm going on right now because I have it set to not take any commands until the homing cycle has been run. So all you need to do to run the homing cycle is going to be just a simple $H, and as you can see, the homing cycle starts to run, and there's all sorts of things you can do based on how GRBL is configured with the homing cycle, multiple limit switches, different directions for the homing cycle. That's where the wiki page really comes in handy. So something to note about this version of Universal G-code sender is the jogging function. And as you can see, when I tell my machine to move, it just doesn't really move. I don't know why, but it sends this $J command, which GRBL says it interprets as what they call jogging. For some reason, mine doesn't work. But if I were to send it without the $J, G21, G91, let's go X100 and send that. And as you can see, the machine is going to move to X100. So a quicker way to run the homing cycle from here is to just press this homing button. And as you can see, the machine will find the home position. Now, what we're trying to do is send the G code that we created with Inkscape. So the way you do that is this file button. Let's see if I can find the Saints logo. Alright, so now we have the Saints logo pulled up, and we should be creating our picture.